Welcome to Building Janky Programs. I'm Philip Forkner, professor at Pierce College here in Lakewood, Washington, and with us also is Jasper Newkirk, student at University of Washington, Tacoma. What's up? Yes. So today I was thinking we were going to talk about the Java collections framework. So that's chapter 11 in the textbook that we're using. And there's just a lot of maybe terminology and stuff that is probably worthwhile to talk about. And I don't even think that I clearly have everything kind of sorted in my brain. You know that I come from a physics background and I hardly ever use object-oriented programming in my code. So just trying to get our brains around what this is, this Java collections framework. So there's this one image, this one table in the textbook that I think is really good. So maybe we can just take a quick look at that. And once I get some stuff figured out here, go ahead and get the screen share going. So this is from the textbook. Hopefully we're not breaking any copyright kind of issues here. But so we have this idea of an interface. And then I think you also talked a little bit about like an abstract class in one of the videos that you made. And so we have interfaces, we have abstract classes, and then we kind of have just regular old classes that we all know and love. And so kind of what's the difference between those things and that kind of thing. And then also, putting all of this kind of collection framework kind of into that picture as well. So I think maybe it's worthwhile to talk about what is the difference between an interface, an abstract class, a regular old class. And then also there's this other kind of thing that's brought up in this chapter is an abstract data type. And so what are all of these things and how do they kind of fit into this, object-oriented programming? I don't know, do you have any thoughts on that?
So we're just focusing on the collections then on the left, right? The left tree.
Yeah, or I think maybe it's even worthwhile just to talk more generally about what is an interface, what is an abstract class, and what is a regular old class, what's an abstract data type, right? Just once, because I think once we kind of understand that, then looking at this diagram, right, makes a little bit maybe more sense, maybe, I don't know.
Okay.
So it's kind of what I'm thinking. So for instance, what's the difference between an interface and an abstract class?
Well, with an abstract class, you can have a method body. With an interface, you cannot have a method body, meaning that all methods are also abstract.
Mm-hmm. Yeah. So in an interface, none of the methods are implemented, and everything in the interface is abstract. So an interface is, maybe you could think of it as like a 100% abstract class. Yeah. And an interface, can it have fields? I don't think so, right? No fields are allowed.
It can have, I believe, only final fields.
Yeah, only final fields. Yeah. So there's not going to be any instance fields, I guess is maybe one way to say it. So an interface is completely abstract and none of the methods are implemented. Okay. But an abstract class, you can have methods which are implemented. And then anything that, so the abstract class, what we extended or we implemented? I think we extend it, right? We extend an abstract class.
We extend an abstract class.
Yeah.
We don't always implement an interface, by the way.
Oh, really?
If you're in an interface, you extend another interface.
Oh, cool. Okay. So you could extend another interface. Awesome. Interesting. So you can extend an abstract class. And so that also kind of limits the number of implementations, right, that you can do. So you can only extend one class, but you can implement as many interfaces as you want. So that's maybe another key difference. And then whenever you implement them, you just separate them by commas. So, public class X, implements A, comma B, comma C, comma D, whatever those interfaces might be. So, okay, so interfaces 100% abstract, generally don't have fields, but you could have a final, maybe like a final field. I think you can even have final methods in an interface. I think since Java 8 or something like that. So interface is completely abstract. Abstract classes may have abstract methods, but also may not. They also can have fields. Yeah. Neither an interface nor an abstract class can be instantiated. So you can't make an instance of an interface or an instance of an abstract class. Okay. Yeah, and then a regular old class that we just know that has fields, methods, and all kinds of stuff, right? So just kind of be everything, I suppose. Can a regular old class have an abstract method?
I think so.
I
As long
think,
as you,
yeah.
as long as you say it, yeah.
Yeah,
I don't see why not.
Yep. So you could have an abstract method in a regular old class, even though the class isn't itself abstract, which is kind of weird. Yeah, I don't know. Like I said, I'm still trying to get my brain around all of this stuff. And why the geniuses who created Java, did this. Yeah, it's way deeper into the weeds than I usually go about it. But yeah. Okay. So to kind of just add to the vocab here, an abstract data type. So they call it an ADT in the textbook, abstract data type. And so we have these abstract data types here, which are listed. There's 6 of them here in the diagram. So we have array lists, linked lists, hash sets, tree sets, hash maps, and tree maps. And so, yeah, so an abstract data type. So let's take a look at an array list. So an array list has certain things that I guess all lists have. They're indexed, I think. So there's some kind of an indexing going on. The linked list is a little bit wonky in that regard, but yeah, so it has an index. You can add things. You can remove things. I think even some of the sort methods are built in to the list interface. So we have this list interface, and what the list interface says is you have to implement these methods. We don't care how you do it, but you have to implement get, remove, add, size, etc. Right? You have to implement these things in order to be called a list. You have to implement this. So we have a list interface, which kind of defines all of the methods that you have to do, even though the list interface itself doesn't actually implement them. But then we have an array list, which implements the list interface, and it does it in a particular way. And so the array list we would call an abstract data type because it implements this list interface, but it can do it in any kind of way that you want to. Now, it turns out that an array list actually uses an array, a primitive array, as a data structure. So it uses this array data structure to actually implement the list interface. So maybe the primitive type array we would call that the data structure. The array list is kind of the abstract data type, which implements the interface list. How's that?
That's a lot.
Yeah, something like that, right? And then a linked list is another abstract data type. It uses, I guess, it uses nodes. So it implements the list interface in a completely different way, right? With these nodes that are kind of linked together. I'm sure we'll talk a lot more about linked lists as time goes on. But yeah, it implements the list interface. but in a different way, uses a completely different data structure to do it. So array list and linked list are both lists, and they're kind of these abstract data types that implement the list interface. I don't know. And then the list interface kind of implements the collection interface. And so why do they have dotted lines here and solid lines here? Is that there must be some kind of a distinction there? I don't know why they're doing that.
Yeah. So you know how I was saying that if you have an interface, you don't implement another interface, you extend it.
Okay.
So list extends interface. So if it extends, then it's solid, and then if it implements, then it's dotted.
Okay, cool. So array list and linked list are dotted because they both implement the list interface. And then from list to collection is solid because the list interface extends the collection interface. Cool. I like it. I like it. Okay. And then we have the set interface. And so we have the hash set and the tree set. The Building Java Programs authors, the authors of our textbook, they do an excellent job of making some videos about this. So highly, highly recommended. Go watch those. They go into some detail about, the differences between all of, a set and a list. And also, of course, the textbook is great. So you can get some more reading on there. And then, of course, Google, but yeah, so we have a set here. And the main thing I think that distinguishes a set from a list is that a set is none of the elements are repeated. So they're all unique in a set. And so, whereas a list, you could have multiple occurrences of a particular element. So like if you have a list of names, you could have Philip multiple times or whatever in a list, like a phone book or something like that. Whereas in a set, the name Philip would only appear once in that entire set. And I think that's the main thing that differentiates them. A set also isn't indexed. I think what are some other differences between a set and a list? Set's not indexed. I don't know. There's some other differences too.
No duplicates.
Yeah, no duplicates. No duplicates. And then we have the map interface. And so a map is just it's a key value pairs. So I don't know. One of my favorite examples is just like a dictionary. So the key would be the word, and then the value would be the definition of that word. So it's just like a dictionary, and it's just a list, I guess, of key value pairs. So that's a map. Yeah. I don't know. I think that was the main thing I wanted to talk about, was just the difference between an interface, an abstract class, an abstract data type, and just a regular old class.
Yeah.
Yeah.
You wanna pull up an IDE and mess around?
Sure. Yeah. Yeah. I have no idea. I didn't think of any kind of an example that we might do though. But yeah, we could maybe, I don't know. What do you want to do?
Well, I have an example.
Oh, okay, cool. Anyway. All right. So what are we doing?
We're doing a new class, calling it main. I don't know.
Main. Okay, sure.
Okay. So if you could, in the main method, create a new array list.
Okay, do you want to call it list or do you want to call it array list?
List, but you need to do it in the main method, right?
Oh yeah, of course. I always do that. And I'm like, why won't my program compile? Oh yeah. Yeah, we're gonna do integers.
Sure.
Okay. And we're gonna do an array list, right? Yes. And I need to import the java.util. Oops. So I don't know. I think we've had this discussion before. As far as the namespace, I always just use star. I don't know. That's fine. Yeah. Anyway,
there is a difference, but
I mean, it's just the namespace though. It's not. It doesn't like take up any more headroom, or it's not slower or faster or anything, right? I think all it does is it changes the namespace, as far as I know.
Yeah, with that, there's things we don't have to worry about. No, there's not a noticeable difference.
Not okay. So there is a difference. Okay, so we'll leave it at that. I just don't know what it is. Okay.
So on the list, if you could add like, 1, 2, 3.
Okay. Okay, let's see here. So I'm going to do the I'm just going to put it in the constructor here. So we'll do a list. I think this is maybe easier. List
Mm-hmm.
of and we'll do pi again. You know, I always like to do pi. 3141592.
Okay.
Okay.
So now, uh, if you could do list dot trim to size.
Trim two sides. So that's not built in, is it?
It is.
Oh, I don't see it.
Mm-hmm. It's because it's you instantiated it as a list.
So I'm still confused. So
So change list to array list
okay. So
on
it's
line 5. And then now call list dot trim
okay.
to size.
Okay, so it only exists in the array list. Gotcha. Trim to size.
That's a little difference.
Yeah.
So this method's pretty cool. So it'll trim the array list to be the list's current size, and that's like under the hood.
It's going to trim the array list to be the size of the list.
Yeah.
Oh, got you. Because the array list by default is much bigger.
Yes.
Yeah. Okay, got you. Okay. Oh, neato burrito. All right.
Yeah. So in a sense where we talk about, what's the because usually when you're using something like an array list, right? The main benefit is that it's indexed. But, you could also achieve the same thing with a hash map most of the time faster, right? This is a conversation. Anyway, if you trim it to size, then that gets rid of the size issue that comes with using a hash map.
Right on.
Yeah.
Cool. So just to be clear, so what array list does under the hood is, so even though we created a list of just seven integers, array list allocates enough space for, I don't know, a lot more than 7. So there's this big chunk of memory in the computer that's set aside for this array list, and it's not using all of it. It's just using enough for seven integers. So when you trim it to size, you just get rid of all the extra kind of fat, and so now you're just using enough space for 7 integers. Yeah.
Absolutely.
Yeah. So just taking up a bit less space. Cool. All right. So I like it. Good example of the difference between the abstract data type array list that's implementing the list interface. So whenever I had declared list as instead of saying array list, when I just called list a list, right? Then the trim to size doesn't exist in the list, in that list interface. And so, but array list does implement this trim to size method. Cool. I like it. Yeah, this is, I don't know, it's still confusing to me because like here, I think technically, even though I'm calling this variable list, lowercase l, as a list of type list, list itself is not a type. I know, it's so confusing. It's not actually a type, it's an interface. Array list is the abstract data type. It's the type. Yeah, I don't know. It's kind of weird. I don't know or maybe I'm just completely talking out of my ass. I don't know. Yeah.
No, yeah, no. Yeah, so when you say list, integer list is a new array list that says, okay, this is a list. We cannot instantiate lists, so we can assume that based off of all the method declarations in the list interface, the implementations for all of those methods are provided by array list, but it itself is a list. So it's kind of like a pseudo object. It's really weird.
Yeah. So why would we want to use, for instance, just list? Of course, if we do that, we can't use trim to size anymore. So that has to go away.
Mm-hmm.
Incidentally, I guess what we could do, okay, let's be fancy here. We could cast the list into an array list. I think we could do something like this, try to cast it. Since list is an instance, so we could do something like that, I suppose, if we wanted to get around it. But yeah, what's the advantage of using just list instead of array list?
Well, if you treat everything as a list, so say you had a method that, did some stuff with an array list, make it, take in a list and return a list. Now, if later on in the program you go, actually, this would be faster if I used a linked list, you could change it in one line and everywhere it would accept the linked list. Or maybe it works for one method to use an array list, maybe another one works better for a linked list. Then you can, mix and match as you please using just list the entire time.
Right on. Yep, for sure. So here we have some dummy method, doesn't do anything. All it does is just returns the list back. Oh, I guess I can't pet void here, right? I have to return a list. And I could probably get rid of a bunch of like diamond brackets things, but anyway, it's just some dummy method that takes a list and then it just returns it. So it's kind of pointless. But the point here is that the parameter is a list. And I think this is what you're saying. So I can take any list, could be a linked list or an array list. And so if I write all of my code using parameters, lists as parameters, then all up here on line 5, if I want to change the implementation everywhere in my code to be linked list instead, I can just change it right here. And since linked list is a list, or at least it implements list, then all of my methods that use lists as a parameter are going to work just fine.
Mm-hmm.
Yeah. Cool.
But the advantage is only there if you implement it in all of the methods like that.
Yeah.
Not just the declaration.
Yeah. And then of course line 7 is going to break now. We're going to get a runtime error on that one, I believe. So it'll actually compile, but I don't think it'll run. Yeah. Whoop, illegal start of expression. What did I do?
You put the method in the method.
Oh my gosh. So yeah, those of you out there who do stupid stuff like that too, don't feel bad. I do it all the time, especially when you're all zoomed in like this. It's hard to see everything. But yeah, okay, let's see if we can get this to run. Yeah, so it doesn't like linked list cannot be cast into an array list. So it's kind of funny. That's the other thing that kind of confuses me is that Java will compile this, but it won't run. So it's just like it just doesn't know that list here is a linked list. I don't know.
Well, you could check, right?
Yeah, you could use the instance of, I guess.
Mm-hmm.
Okay, so let's go ahead and fix that. So let's see. I guess we can just say if list is an instance of what do we want? Array list.
Integer. Yeah.
Then we can do that. Cool. So it ran. This time it ran. We didn't do anything. Cool. All right. Abstract data types, interfaces, abstract classes, kind of how it all works, just how it all fits together. Yeah. So there's some, I think, the code step-by-step problems. I think maybe it'd be fun to do some problems at some point. I don't know if we need to today, but yeah, I don't know. I just wanted to give this kind of quick introduction into kind of the Java collections framework and kind of just talk a little bit about what the differences are between these vocab words: interfaces, abstract classes, abstract data types, right? So hopefully now it's a little bit clear on kind of what all those things mean and what they are. Cool. Anything else you want to add?
Um, no, not really. Maybe mentioning that so the trim to size will not affect, like when you call size, like the size method, it will not affect that. It has to do with what's underneath the hood, right? Because the array list is an array, a primitive array. So you have to like set it to be some kind of size and it'll move that array, but that does not affect the size method in the array list class.
Yeah, it's kind of interesting too, because so let's see. So whenever let's go take our list and take it back to an array list. So what we said was that what array list does under the hood is it uses a primitive type array, sets aside a bunch of space for a bunch of integers. And then we're gonna use the constructor. We're gonna fill it up with 7 integers, but there's plenty more space in that array for many more integers. We're only using 7, and so array list has a field called size, which is 7 in this case, even though the underlying data structure, the primitive array has a much larger size than 7. But array list keeps another kind of variable, a field called size, which is 7 in this case. And so even though you're changing the size, the size in memory, it's not affecting the field size. It's still 7 integers.
Another thing you can do is in the constructor of the array list, where you usually put list.of, right? If you don't have any like leading, list.of thing, you can put in the initial capacity you want the primitive array to be. So say you're expecting 64 values in the array list on initialization. You can say 64. Well, that constructor is kind of off. Right.
Oh, yeah.
But yeah, so that'll set the initial capacity of your primitive array. So if for whatever reason you're tied on memory, that could be really useful.
Okay. Cool. Love it. Like it. Nito burrito. There was a question that came up during the discussions in Canvas was, no, actually it was a question on our YouTube channel. Let's check it out. And I kind of put, let's see, what did I put? I answered it. Hello. So the question was from Unlucky Chord. Knowing what an array list does, why would we use the primitive type array instead of an array list?
Memory.
Yeah, memory. So yeah, so there's lots of reasons, but probably the main ones are primitive types have less overhead, so kind of less memory. You don't have to worry about wrapper classes. Primitive arrays might even be a little bit faster. I don't know. I feel like primitive arrays might be faster, but I don't know why and if that's even true.
It would depend on what you're doing.
Yeah.
So, you can think of an array as having O of 1 access, or, it can grab things immediately. However, you may, or array list, say for whatever reason, the array list access in Java was O of n, then yeah, of course, it would be faster to do it yourself. There's tons of ways that you could manipulate an array to somehow do it faster, quote unquote, right?
Sure.
So
yeah, there might be, what I actually meant was like literally just access. So like if we say, list get, 5 versus, array A open bracket 5 close bracket, right? I just mean that. I don't know. I think that the primitive type array, just accessing an individual element is actually faster, but I don't know.
well, yeah, you're skipping a step, right? You're not going into a new context and grabbing the method body and running it and returning something and then putting it in place of it.
Right. Yep. So instead of having to call the get method from array list with a primitive array, you just have open bracket, close bracket. And you don't have this extra overhead of having to call the get method. Cool. So maybe slightly faster. And and I'm sure, again, the geniuses of Java, they've probably optimized, lots of things to make it faster and whatnot. So maybe that's not even a good reason to use a primitive array over an array list. But yeah, the wrapper classes, the overhead of an array list, so yeah, cool. All right, we ready to end this thing?
Yeah.
All right, that is the end of another Building Janky Programs episode. Thank you all for watching. We'll see you on the next one. Like and subscribe, all of that stuff.
Bye-bye.
Bye-bye.